Hello everyone, welcome to the class. Just give me 2 minutes. Let me just check if I'm online. Alright, welcome everyone. Welcome back to the class. And in today's class, we are going to be covering topics from physical world and measurement. We would be actually looking into the concept of what is accuracy, what is precision, and about error analysis. Alright, on that note, my name is Mohana. I'm a physics educator here at Unacademy. So if you're taking your class 11 and 12 physics with Unacademy, I'll be teaching. The link to my Telegram channel is given here. And as well as any update before any classes goes live, I would be updating about the same in this Telegram channel. And at the same time, the link to the this is the link to the Telegram channel for the common Unacademy and ICSE and ISC Board common Telegram link. So you can follow in both the channel as well. All right, and also just like how we have the free classes on this Unacademy, on the YouTube channel, right? ICSE and ISC YouTube channel. We also have free classes on the Unacademy platform as well. So these classes are absolutely free, so you can learn from any of your favorite educators, right? You can learn from for free, and you can engage with those educators via pool feature. So this is an interesting feature you can check out, and also as well as you can get your doubts cleared. Since these classes are live classes, you can get your doubts cleared as well. Now the link to the upcoming special classes are down in the description, so you can just go there and go to class 11, right? And you can click on the class 11 description link, and whichever class you want to. There would be a lot of upcoming special classes, so you can just click on the class you want to enroll to. You can enroll in all of those classes and just click on notify me, and you can give whichever contact details you want, or in which way you want to be notified, in which mode you want to be notified, right? So before the class goes live, you will be notified regarding the same. Now these are the upcoming special classes. So if you see, we have on 20th June, because we know on this channel we have simultaneously started teaching unit 2 as well, right? When you're doing unit 1, we are also learning unit 2 as well, right? So here what you can do is on 20th June, right, we have a topic that is for application of vectors. So in this class we'll be looking into practical applications of vectors. Okay, so we'll be learning vectors through a lot of examples, so you can enroll for this one. And on 27th, this is at 4 p.m. So this is a basic mathematics class for physics. So in this class we'll be covering differentiation and calculus. Okay, and on 29th, again we are having the practical applications of vector part 2. Okay, you can check out all 3 classes. So all of these 3 classes happens by around 4 p.m. all right, and you can check them out in the description box as well. Now if you're interested in taking the plus subscription, right, then there are the advantages are you can learn from the comfort of your home. And whenever you're taking a plus course with Unacademy, you're taking 4 subjects. You're getting 4 courses. One is physics, math, chemistry, and biology. All 4 courses you will be taking, right? And you're learning from the top educators, and as well as if every 4th class. So we have an interesting feature in the when it comes to plus classes, that is every 4th class would be a doubt clearing session. Okay, so whenever you're taking a course, so if, let's say the first 3 days, whatever concepts you're learning, the 4th day, if you have any doubts regarding them, you can get those doubts solved. Okay. Now in a plus subscription, right? So in a plus subscription, we will be exhaustively covering all of your syllabus, right? All of your topic would be covered, and there are practice tests, but also we have some few live test series. Okay, so in this live test series, you take the live test series, and this happens every other week, and there would be analysis session followed by this test series as well. Okay, now after this, we have an upcoming batch. I'll give you the details a little later, but right now the course pricing, if you look at the longer duration course you take, the price per month comes down, right? Instead of taking a 3 months or 6 months course, right? If you're taking a 2 years course, right, then the price that you're paying per month is actually low. You're just paying 1198 rupees per month. Now on top of it, if you're using my educator code MTIS10, then you will be getting a 10% discount on the same, right? Then you're getting the course for just 1078 rupees per month. So you're getting 4 subjects for this cost. All right, and you can use my code for the same. Now the ongoing course that we have right now is actually, it started on 8th June only. We started only on 8th June. So the mode of delivery for this course is going to be in English. So I'll be taking physics, and we'll be meeting every 5:15 to 6:15, Tuesday, Thursday, Saturday, right? And in this course, if you see, in a plus course, right, if you take for 1 month, if you're just looking at 1 month, for 1 month you will be getting 10 classes in physics, a minimum of 10 classes, right? And minimum of 10 classes in math, minimum of 10 classes in chemistry, and minimum of a 10 class in biology. Okay, so in a month you'll be getting a minimum of 40 classes, right? This is the amount and for the amount you're paying, minimum 40 classes a month, so that's 40 hours, minimum of 40 hours. Other than this, there will be live test series and analysis session as well. And at the same time, if at all, if you're in class 11, then there is an advantage for you. If you're taking the class 11 subscription, class 12 subscription is absolutely free. All right, on this note, let's begin today's topic. So today's topic, we are going to talk about errors and what are the ways, right? Error and error analysis. This is your topic today. So every time, right, you make a measurement, okay, sometimes there could be an error in your calculation. This could be because of the person who's taking the measurement, or because your instrument is faulty, right? So every measurement that you're making is limited by the relatability of the measuring instrument, right? How good the instrument is, and the skill of the person who's taking this instrument, making this measurement, right? So, so from here we can say, all right. From here, normally when you do an experiment, and if you keep repeating it, right, I'm sorry about that. Normally if you do an experiment and if you keep repeating the experiment multiple times, like, you may not be getting the same value all the times, right? So the imperfections in measurements can be described in 2 ways. So one is basically accuracy, another one you can say is precision. Now when you're talking about accuracy, you're talking about how close the value is to the true value, okay? Let's say the actual value of a particular weight of a particular object, let's say it's 5 kgs. Okay. Now, when you are actually measuring it, how close it is to that 5 kgs, that becomes your accuracy. Is it around 4.99, right? Or around 4.98. Now, this means your value is very accurate. Now, when you're talking about precision, right? Normally when you're talking about precision, what you mean is that, let's say you're taking repeated number of readings, okay? And Akshay, good evening, Akshay, good morning, right? And by the time, and if you're talking about precision, right, then you're talking about how close the value is related to, let's say it's about 5 kgs, and every time you measure, let's say you're getting 4.95, 4.94, 4.95, right? Then we can say the particular value is precision. All right. To understand what is precision and accuracy, let's do it with an example. Okay. Now let's say you're playing a game of dart. Okay. And let's say your target is around this place. Let's say this is your target. Okay. But this is where the target is. This is where you want to, this is exactly where you want to hit. Right. Now, right. Let's say in this game, you're hitting somewhere, let's say you are throwing the dart, okay, and you're hitting somewhere over here, let's say somewhere over here, here and here, okay. With respect to accuracy and precision, what can you say? With respect to accuracy, does it have a good accuracy? Does it have a good precision? This is where the black mark is where you want to hit, but this is where you have hit everywhere. All the places you have hit, it's all the way around. Right? So what can you say about the accuracy or precision in this case? If you see, the value is not very accurate or precise. Why? Accuracy, when you're talking about, it's about right, that's no. When you're talking about accuracy, it's about how close you're hitting towards the target, right? In this case, if you see, it's all the way around, right? So it's not very accurate. Precision means how close you're getting. If you're taking two readings, how close those two readings are, right? But if you see in this case, this is also everywhere around. So this is an example of a low accuracy and low precision, right? Now, same case. Okay, same case. Let's say this is your target again. Okay, but this time, let's say this is where you're hitting. Every time you hit the dart, this is the region where you're hitting. So what can you say about accuracy and precision in this case? Is it very accurate or is it very precise? Okay, so in this case, if you see, accuracy, when we said, it was how close it is to the actual value, right? Now this is very far away from the actual value, so it is not very accurate. Okay, it has a low accuracy. Okay, but what about precision? When we are talking about precision, what about precision? In this case, we can say the values are actually very much precise. Right? Yes. Akshay, over here it is low accuracy, but as you said, it has a high precision. It has a high precision. All right. So this one has a low accuracy, but it has a high precision. All right. Now let's do the same one. Let's do one more example, right? Let's say in this case, okay, let's say the value is everywhere around. What can we say about it? How is its accuracy? How is the accuracy? And how is the precision? Accuracy is how close. Okay. All right. So accuracy is how close the value is to the given value over here, right? Accuracy is how close it is to the exact value. So if you see, this is very close towards the target. So we can say accuracy is actually high. But what about precision? Precision is how close each value is to each other, right? So if you see over here, this one, all of these are close to each other, right? But this one is really spread out. So this has a high accuracy, right? We can say the accuracy in this case is high. But if you're looking at precision, precision is actually low, right? So if you're talking about a reading which has both high accuracy, at the same time it has a very good precision means, right? Let's say this is the target, right? This is your target, and let's say this time you're hitting when you're playing dart, you're hitting in this location. Okay. Now if you see, the values are close to each other, right? When they're close to each other, when you're repeatedly throwing the dart, all of these values are close to each other. Then we can say this one has high precision, right? As well as when you are actually taking the, if you look at the accuracy right now, okay, right, actually it is close to each other, right? In this case, it is close to each other, so precision is high. But at the same time, this is the target location where you have to reach, and you've hit very close to it. So you've hit to a place, right? You threw the dart, and the dart has landed in a place very close to the target. So when the value is very close to the target, then we say it has a very high accuracy as well. So this is a good example of high accuracy, right, and high precision. All right. So I hope that gives you a clear picture of accuracy and precision. So on that note, let's learn about the definition for accuracy and precision. So whenever we are talking about accuracy, now this refers to the closeness of the measurement to the true value for physical quantity. Okay. So let's say you're calculating the mass of, or let's say you're finding the diameter of a cylinder. Okay. And you're finding using a screw gauge, and you're finding it to be somewhere around let's say the actual diameter is 5 millimeter. Okay, sorry, 5 centimeter, and you're finding it somewhere close to 4.99 centimeters. Okay, then we can say the actual then they can say the value is very accurate. Why? It is very close to the actual value. Okay, so here if you want to get a very high accurate value, okay, then you have to reduce the errors. Okay, if the error is reduced in the measurement, in case of instrumental errors, okay, in case there is an error in the instrument, or when you're taking a reading, if you are making an error, okay, so if all of the errors are reduced, then the actual value becomes more accurate. Okay, so when you're talking about accuracy, you're talking about how close that value is to the actual value. Now, what about precision? When you're talking about precision, okay, this refers to the resolution or the limit to which the quantity is measured. Okay, now this one is like when you're repeatedly taking a value, how close each measurement is, okay, and whether you're able to get very close to that measurement. It talks about this. All right, so precision is whenever you're talking about precision, this is determined by the least count of the instrument. Okay, if the instrument has a smaller least count, all right, then then you will be able to get more precise values. In that case, the precision becomes much more greater. Then the precision will increase. All right. So precision refers to the resolution or the limit to which the quantity is measured. Okay. And when you're talking about accuracy, it refers to how close a value is to the true value. All right. I hope this is clear. So on the I hope this measurement is clear. On that note, let's do a very simple question. Based on what we have learned till now, right? I have a very simple question to ask. So thank you, Akshat, for that. Let's say you're measuring one measurement, you're getting 5.2 grams. Okay, let's say you're measuring the mass, okay, of some object, and you're getting 5.2 grams in the first reading, and so let's say you're getting 5.1 grams in the second reading, and let's say you're getting around 0.50 grams in the third reading. Okay. If you take the average of all three readings, that will be the actual reading of that particular mass, right? Let's say you're measuring what is the mass of a ball. Okay, so every time you measure the mass, you're getting different reading. So if you take the average of them, right, that will be the actual mass. So in this case, if you see, you got 5.2, 5.1 and 5.0, right? Now, are these value accurate? What can you say about it? What can you say about accurate and precision? So in this case, if you're taking the average, we can say average is around we can say 5.1 grams, right? Average is the mid value. In this case, we have taken is 5.1 grams. So here, what can you say about the accuracy or precision? Is this value accurate or precise? Just give me 1 second till you answer. Let me just see. So if you see, these values are extremely different, right? All of them are at one point, right? Each value that you're taking, all of them are different. So if you look at these values are neither accurate nor are they precise. Why? Because each of the values is different, and it may not be giving it's not very accurate as well, right? But when you're talking about all right, so now just a minute, I'm having a bit of a technical difficulty. All right. Okay, all right. Now let's say you're measuring the mass of okay, some other instrument, and let's say you're getting around, I'm sorry, just a second, one more second. Okay, so let's say you have a value of around 0.412 grams. Okay, and let's say again you're getting 0.415 grams and you're getting 0.414 grams. Okay, now say let's say this is 0.416 grams. Okay, here these values are very precise. If you see, the least count itself is less, right? If you see, we are getting up to 3 decimal place values, right? So if you see, if you just take this value, right, if you take just the 2, if you convert it into just 2 places, 2 significant digits, you can see the values are very precise. Precise meaning you're getting the same value over and over again, right? This can be like 0.42, 0.42, right? And this is around 0.41, right? So if you see in this case, the least count is actually less, right? So less least count means you'll get more precise value, but it's not very accurate, right? The values in this case are again not very accurate. But at the same time, let's take one more set of values. Let's say this time you're having 0.216, right? And let's say again you're measuring, again you're getting 0.20 grams, okay? And 0.520 grams, okay? Now if you take the average of all of them, you will get 0.520 grams, right? This will be the average, right? Now if you look at this, you have a much more, least count is also more. And if you look at the readings, they have repeated itself, right? And whatever value that you're taking average of that, if you see, it is almost, the values are very close to each other. It has about 3 decimal points you're getting up to. So this particular set of values are more precise. At the same time, they are much more accurate as well. Okay, because whatever measurement you're getting, that when you're taking, that is correct, equal to the true measurement. So whenever you're taking the average of value of the, whenever you do an experiment, right, you take the average of that value, that will gives you the true value. All right. Next is let's see about the different errors that you will get in when you're doing measurement. Okay. So the errors in measurements are the errors. It's whenever you're talking about an error when you're doing a measurement. Okay. Any sort of measurement you're making with an instrument will mostly have one error or another. Okay, so the error in measurement, whenever you're measuring it, the errors could be because of different reasons. All right, but when you're talking about error, okay, the error in a measurement is equal to the difference between the true value and the measured value of the quantity. Okay, so whenever you're taking, let's say the value you're getting is around, let's say you're finding the length of this particular pen. Let's say the pen's actual measurement is 13.5. But when you're measuring, right, when you're measuring, by mistake you had not started, let's say you're taking the scale and from the 0 marking of the scale you did not measure, and by mistake you measured from the, let's say whenever you take a scale, right, so there is a part of the scale that is free, right, and only if there is a part that is left blank, and after that the division starts, right. Let's say you're measuring the scale over here, and by mistake instead of starting from this point, right, you started from this point. Okay, so let's say the actual value of this pen is around 13.5, right, and let's say you measured it as 13.3. okay, then there is an error of about 0.2 centimeters, right. Now that becomes your error. How much deviation, right? That is right, Akshay. What you're saying is exactly right. Your example is a very good example, right? So here the error is actually true value minus the measured value. Okay, so whenever you're talking about error, it's true value minus the measured value. So there are different types of errors. So if you know about some of the errors, you can give me in the comment box, right? What are the different errors? You can give them in the comment box. So one is basically your constant error, okay, and another type of error, we call it as a systematic error, okay, and then you have random errors, and then you have least count errors, and then you have gross errors or mistakes. All right, now when you're talking about constant errors, now these errors, if you're, let's say you're doing an observation, okay, let's say you're measuring you're doing a measurement, and in the measurement you're able to see every measurement, every reading you take, okay, is constantly has some errors in it. It has a constant error. The error could be around 0.2, let's say in case of length, you're measuring the length of a rod, and every time you measure, you have a constant error of 0.2 meters. Okay, this error is constant for every reading you take, right? Then we say this error then this particular error which affects each observation by the same amount, these are called as constant error. Now, these errors could be because of faulty calibration of the scale, okay, could be an error because of the instrument, because of not maintaining the instrument really well. Okay, now these errors you can eliminate them by measuring by a different number of methods or trying various different apparatus. Alright, so one is constant errors. Next is systematic errors. Okay, these errors, we say systematic errors which tends to occur in one direction, either it in positive or negative. Okay, you can actually eliminate these errors much more easily, right? These systematic errors are further subdivided. Let's see each of the type. One is instrumental errors. Okay, under systematic errors we have instrumental errors. Okay, now instrumental errors are nothing but if there is an if there is a defect in inbuilt defect of the measuring instrument. Okay, then we say that is an instrumental error. If you know of any example, if you can think of any example, you can actually give it in the scale, in the reading. Okay, let's say you have your vernier caliper, right? Okay, so in the vernier caliper, we know you have a main scale, right? You have a main scale and you have a moving vernier scale. Okay, now let's say the main scale division reading and the first division on the vernier scale, if they are not coinciding. They have to, right? The main scale first division and the vernier scale have to coincide. Let's say they are not coinciding. Then this is basically an instrumental error. Okay. Now, these instrumental errors, you can actually rectify them, right? By measuring a physical quantity with instead of using the same instrument, you can actually try changing the instrument, right? In which way you can actually try to rectify this instrumental error. Okay, or again calibrating that particular instrument. Okay, that will also rectify this instrumental errors. Okay, next one that we are saying is imperfection in experimental limitation. Okay, now these experiments are due to the limitation of experimental arrangement. Okay, let's say you're trying to measure what is the radiation loss, okay, in a calorimeter experiment. Okay, now there could be an error there, or let's say you're trying to weigh an object. What is the weight of an object in air? Let's say you're trying to weigh what is the weight of an object in air. Okay, now the buoyancy of the air, because of that there could be an error. Okay, now these errors you can correct them. Okay, but errors, these errors, right, you cannot be eliminated. You cannot just eliminate these errors altogether, but you can actually change the condition of your experiments, right, for getting a proper value, all right, to get a better accurate value, right? And then personal errors. Okay, these errors happens in case due to individual bias, or in case there is a lack of proper setting of apparatus, or individual carelessness in taking observation, right, without observing or proper precautions. For example, let's say you're trying to read you're trying to take the value, right? You're trying to read some value from the scale. Okay, so instead of reading it, looking at it straight and reading, let's say you're tilting it or keeping it towards the side and trying to read, right? Then what will happen? There could be an error because of parallax, right? Hello, and when will Unacademy launch? Alright, so what you can do is, if you want the answer to this query, there might be a number in the description box, right? You can try calling them and asking about the same, or you can try any of the comment channel of Unacademy, right? You can just try writing them a mail or asking, so they might redirect you to the right patch. Okay, alright. So these personal errors, you can actually correct them by actually, if you are having by repeating the experiment different number of times, okay, or by doing the observation much more carefully, all right, then these errors, personal errors, can be avoided. The last one in the systematic errors is errors due to external causes. Okay, these are because of external causes, like when you're doing an experiment, the change in the there could be an error because of change in temperature, pressure, there could be wind, etc., right? These could actually change. Let's say you are taking a scale, and because of the heat, right, let's say there is an expansion because of the temperature, there's an expansion in the scale, right? Then these errors, then there is a possibility of an error. Okay. All right. Now, so from here we saw there are 4 types of systematic errors. One was instrumental error, then we have imperfections in experimental technique, then we have personal errors, and then we have errors due to external causes as well. Okay, these come under systematic errors. Next, what are random errors? Okay, these errors which occurs irregularly and at random. Okay, these errors occur in terms of magnitude as well as in direction. So these are called as random errors. Okay. So this could attend because, you know, these could arise because the person who's taking the readings, right, is not being very attentive. Okay, and these okay okay, so for example, let's say a person is trying to take a particular reading, and he's trying a different number of times, and every single time he's getting a different reading. Okay, so when that happens, the random errors have a chance of being positive or negative, right? How do we get errors, right? Let's say this is, let's say a weight, or let's say the mass of an object is 5 grams. Every time the person takes a reading, let's say he gets 4.9, right? He say, let's say 4.8, 4.9, he gets 5.1, 5.2. What will be the error in this case? Error will be around when the first one is 4 minus, in this case 5 minus 4.8 is 0.2, right? Then this will be 0.1. But in this case, if you see, this will be again, in this case it will be 5 minus 5.1, right? 5 minus 5.1. So this will be minus 0.1. This will be minus 0.2. So random errors can be positive or negative. Okay. So because of this, you can take the arithmetic mean of large, if you can take a large number of observation, you can take 5, 10, okay, you can take many number of observation, okay, and you can actually take the arithmetic mean of all of these value to get the actual value. All right. Okay, now if you take this value and if you take the mean of all of these value, that will come close towards 5 grams. Okay, so in that way that we can avoid these random errors. Next is your least count errors. This error is due to the limitation imposed by the least count of the measuring instrument. Okay. Now, whenever you're talking about least count, you're talking about the smallest division on the scale of the measuring instrument is called as the least count, right? So if you're talking about the least count of a meter scale, right, it just has it just has a least count of around 1 mm, right? So so in that case, the readings are only good up to this particular value, right? So these are basically least count errors. Okay, and the last one is what is gross errors. These are due to either carelessness of the person or due to improper adjusting of the apparatus. All right, these leads to gross errors. So these are the types of errors that we have seen. All right, we started with constant errors. Constant errors, in case if the error is occurring by same amount in all of this observation that you're doing, then we say it is a constant error. It could be because of a faulty experiment, right, apparatus. Then systematic errors, it could be because of instrumental error, or in case if there is an imperfection in experimental technique, that's another error. Another one is personal errors, like if you are making mistakes while taking a reading, or if there is an error because of any external conditions like pressure, temperature, the temperature can expand the scale, right? So in that case you will get a wrong error, right? So these are error due to external causes. Then you have random errors. This occur irregularly and at random. It can occur both in magnitude and directions. Okay, these are called as random errors. Least count errors are these errors is due to the limitation imposed by the least count of the measuring instrument, right? So if you have an instrument that gives you a very good least count, if it can go up, measure up to 3, 4, like after decimals 3, 4 point values, then you can actually take, right, take a very good, you can get a very precise and an accurate value. In which case, when that is not possible, right, then you will not get a very accurate value, right? So think of measuring this length of the using a meter scale, or let's say, and the length of the pen using the vernier caliper, then I will get using, see, if I get this as 13.3, in using a least vernier caliper, I might get the length of the pen to be 13.35, right? And if I use and in case if I want to measure the thickness, and then in a vernier caliper I might get only up to 0. Let's say this is around 2.5, okay, and 2.52, but if I use a screw gauge, I'll get one more division, 2.523, right? So the greater the least count value lies, right, then the measurement when you're taking, the values becomes much more precise. Okay, then you can say that these errors because of this least count can be minimized. Okay, and then the next one is gross errors. This is because of carelessness of the person or due to improper adjustment of the apparatus. Now we have seen what are the different types of error. Now what is the way to avoid them? Okay, to eliminate errors, right, we can actually make use of the Norman or the Gaussian law of random errors. Okay, according to the Norman or the Gaussian law of random errors, what it basically says is when you take a lot of observation, you might get a positive. The number of positive values and negative values you're getting, you might be same. I gave you an example just previously, right? How you in random errors, how you're getting a positive and negative values. So the number of positive values you're getting, that might be the same as the number of negative values you're getting. Okay, so you can actually minimize errors, right, by repeating the experiment a large number of times. Okay, and then taking arithmetic mean. So the arithmetic mean of all the measurements can be taken as the true value of the measuring quantity. Okay, so let's say you're doing an experiment and you found, let's say you're finding the length of the pen, okay, or you want to find the diameter. Okay, so first you measure using a screw gauge, right? First reading you take, that will be A1, then second reading you take, that will be A2, the third time you measure, let's say that is A3, and so on. You measure for n number of terms, so you can take it as AN, right? So from here, the arithmetic mean, we give it as arithmetic mean this way, or A with a bar on top also means arithmetic mean. The arithmetic mean will be what? Mean is the total sum of all observation by number of observation. So here, what is the sum of all observation? That will be what is my first reading plus my second reading and my third reading, right? And so on up to what is my nth reading. Okay, that is my sum of observation by how many observation you have done, right? We did a total of n number of observation, right? An represents how many observation we did. Is it 10 observation we have taken? Then it will be 10 values divided by 10. Sum of observation by total number of observation. If I want to write it in a more generalized form, then I can write this as 1 by n, right? I'm taking 1 by n commonly, and A1 plus A2. So this you can write in a very much more generalized form. Right, you can write this as summation, right? You can write this as summation I is equal to 1 to the n, right? You can write AI. So this AI takes the value when A is equal to 1, you get A1. I is equal to 2, you get A2. I is equal to 3, A3. That goes on up to AN. Okay, so this is the basic equation for finding the arithmetic mean of all the measurement. All right. Now, from here, what are the different types of errors analysis we can do? Let's check that. Okay. The way to eliminate the errors, the first one is actually absolute error. Then we see what is a mean or fine absolute error, then relative error and percentage error. Let's see each of these cases, and depending on the time we have, we will do an example question as well. Okay. First one is we are seeing what is an absolute error. Okay. Now this absolute error we take for each of the individual readings. Okay, and then we are going to see what it's the magnitude and what is the difference of each individual reading from the true value. Okay, so when you take the arithmetic mean, you actually get the true value of that particular value. Like if you want to find the diameter, if you want to find what is the radius of this particular pen, right, or if you want to measure the thickness of this particular pen, what you will do, you will use a screw gauge, take different measurements, and you will add all the measurements and divide it by the total number of how many measurements you have taken, right? When you find the mean of that particular value, then what you will get the true value of this actual pen. Okay, now what will be absolute error is very simple. For every reading you have taken, you're going to subtract it from the true reading. Then you get absolute error. Okay, so the magnitude of difference between true value of the quantity measured and the individual measured value is called absolute error. Okay, so in this case, let's say in this case we have found the arithmetic mean, right? Earlier case we saw what is arithmetic mean, right? Arithmetic mean is given by a bar or a mean, right? This is given by arithmetic mean. We just saw that in the previous one, right? We took it as first reading, second reading, right, and so on to the nth reading divided by n. This is your arithmetic mean. Now what we are going to do, when you're talking about absolute error, right, the absolute error is, we are going to check how each of the reading, right, let's say the first one, how each of this particular measurement is different, or how much off it is from the mean value. Okay, so this will be delta A1, that will give you the absolute error of the first reading that we have taken. That will be A bar minus, okay, A bar minus, this will be the mean value minus A1. Whatever value you are getting, that will be the absolute error for that particular value. Okay, similarly, absolute error for the second one will be mean value minus the absolute error of the second one, right? Again, for the third one, it will go on up to, okay, it will go on up to the nth one, right, nth term that you want to find. What is the mean value minus the nth term value? Okay, that will give you the absolute error. Okay, next is basically what is your mean absolute error. Right now, you've actually found the absolute error for all of these values. Okay, now when we learned about random errors, what did we learn? We learned that they could be in the positive or in the negative. The values are getting over here, it could be positive or negative. So when you're finding the mean absolute error, very simple, you are actually finding the mean of all of these values. What is the mean of all of these values? But since these values could be positive and negative, and they could actually mean right, Prabir, right? Okay, since they could actually cancel out each other. So what we will do when we are taking absolute error, right, mean absolute error, we only take the positive magnitude, the arithmetic mean of the positive magnitudes of all of these absolute errors. The positive magnitudes of all of these absolute error, if you're finding the arithmetic mean of them, that gives you the mean absolute error or final absolute error. Okay, so that will be what? Delta A bar, right? This is delta, meaning this is for absolute error. Okay, what is the absolute error? Will be equal to, what is the absolute error for the first one, right? What is the absolute error for the first one? Okay, to the absolute error of the plus the absolute error of the second reading, okay, and so on up to the absolute reading of the nth term, right? All of this by the number of terms. Okay, why we are taking the modulus? I'm sorry, why are we talking the modulus? It's because we want only the we are considering only the positive values, positive magnitudes. Okay, now. Probably right, we take the modulus, that is correct, right? So here we can actually take 1 by n, you can take commonly outside, and in common form, if you, generalized form you want to write, this will be 1 by n if you take. So this part, how would you write this part in generalized form? This part is nothing but summation I is equal to 1 to n, right, delta ai, right, modulus of delta ai. The I taking, when I takes the value 1, you get this value, I takes the value 2, you get this value, and so on, right, to IAN. Okay, this is mean absolute error. Okay, now the next one that you can see is that what is, okay, next, other than this, okay, we also have a relative error. Okay, other than this, we also have a relative error. Relative error is very simple. Okay, so you get relative error by this sigma symbol. Okay, whenever you're talking about a relative error, what you're actually taking is, you're taking the mean absolute value. Okay, if you're taking relative error is given by the mean absolute value. What is your mean or the final absolute value? Okay, your mean absolute value, okay, by the true value of the quantity, true value or actual value. So relative error, you give it as sigma A, right? This is nothing but delta. What is the mean absolute value? That is this value that you found, okay, by what is the actual value. That will give you your relative error, okay. Next what we have, this is the third type of error, okay. Next what we have, the fourth type is actually the percentage error, okay. Relative error, sometimes we call it as fractional error as well, okay. Then we have the percentage error. Okay, why are we calling it as the fractional error? Think about this delta A bar, right? This value will be very small when compared to actually, because this is how much the value is deviating from the actual true value, right? So this is 5, if this is like 5 grams means when you took, let's say you've taken 5 readings and let's say one of the readings is 4.8. So that reading will be what? Delta A1 will be what for that particular reading will be 0.2. Right, then you can say that this value over here, summation, if you're taking of the mean absolute error, mean absolute value, this is a very small value when compared to it. So your relative error, sometimes you will see it as fractional error also. What is percentage error? Percentage error, okay, percentage error basically expresses whatever value you have, it gives in terms of percentages, okay. Now percentage error, you can actually take percentage error very simple. You take the relative error, okay. So you basically take the relative error and into times it with 100 percentage. That will give you the percentage error. So percentage error is nothing but delta A bar, right? You find the fractional error and into that you do 100 percentage. This will give you the percentage error, okay. Relative error expressed, Prabhi, that is correct, Prabhi. That's exactly what you do in case of a percentage error. Alright, so I hope till now whatever errors we learnt about is clear for you guys. And on this note, right, let's try and do one question. Okay, let's do one numerical. So here, let's say you're trying to find the refractive index of a glass. Okay, you want to find what is the refractive index of glass. Okay, so you give the refractive index of glass as mu, right? Let's say you're taking different sets of reading. The first reading you try to fake, right? Because we want to avoid errors, we have to take or to get a more precise and accurate result or a more accuracy, right? If you want your answer to be accurate to the true value, then you have to repeat the experiment multiple times, right? Let's say the first observation, you got the value of refractive index of glass is 1.545, okay? Let's say you did that the second time and you found the refractive index to be 1.56. The third time you repeated the experiment, let's say this is around 1.54, and the fourth time you repeated the experiment, let's say you got 1.44, and the last, okay, and let's say fifth time you got around 1.54, and let's say you did sixth time, okay, with this let's stop. Let's say you got around 1.53. All of the reference questions that I'm doing, all of these questions will be taken from your reference book, okay. So, and here, let's say the first one, that we just know this, we have done 6 set of readings, right? Let's find error analysis for all the 4 types of methods we learned, okay. First one is, first we have to find what is the mean value, okay. First we have to find what is the mean value. What will be the mean value in this case? Okay, mean value of refractive index. Mean value of refractive index will be what? Mean value of refractive index, we can say, okay, this is mu, right? This is the mean value that you're taking. Mean value will be what sum of observation by total number of observation. What is the sum of observation? Prabir, could you just try giving it that question one more time? You've given an answer, just try it one more time. Let's say 1.45 mean the mean value of refractive index means sum of observation, right? How many observations are there? 1.41 plus 1.56 plus 1.54, right? Plus 1.44 plus 1.54 plus 1.53. Okay, this is the mean value of the refractive index by how many number of observations are there? 6 number of observations are there. Okay, you have to divide by whenever you're doing mean value, right? You have to add all of the value and divide by the number of observations. We have taken 1, 2, 3, 4, 5, 6. Divide by 6. That will give you the mean value of the refractive index of glass. Mean value is actually the true value of the glass. Okay, which means it's giving you the actual value towards the whatever the value of the refractive index is. We are getting a very close value towards that. Okay, so in this case, if you add all of them and divide by 6, you will get around 1.51. Now this is the mean value of refractive index. Okay, is 1.51. All right, now what will be the, that is right, Praveer. Now what will be the absolute errors? Now when you're talking about absolute errors, right, we take it for each of them. Okay, we found mean value, that is one case. The second case is we want to find what is the absolute errors, right? So absolute errors we take for different measurements, right? So what is the absolute error for the first one? That is given as delta mu1. Delta mu1 will be what? Absolute error. We always take it as what is the absolute error. Okay, so whenever you're taking absolute error, so it will be what is your mean value. Okay, what is the mean value? That is the true value, right? Minus what is the value you got for that particular reading. Here mean value is 1.51 minus for the first set we got 1.45. So if you see what is the difference between them, 0.06. That is actually your absolute error. In the second case, if you see, right, in the second case mean value is 1.51 minus absolute, what is the second reading you got? 1.56. So difference between them is minus 0.05. Okay. In the third case, if you see, the third case, what is the absolute error for the third one? Because absolute error we take for individual readings, right? This will be 1.51 minus 1.54. So that's around minus 0.03, right? And then you have delta, the absolute error for the fourth one will be 1.51 minus 1.44. This is around 0.07. And then you have for the fifth one as well, right? This will be 1.51, right? Minus 1.54, okay? Which will be equal to minus 0.03. Okay, I hope this is clear how I am getting it. Now the last reading, again the last absolute reading, if you want to find, it will be mean value, that is 1.51. We just found it, minus what is that individual reading value, 1.53. So this is around minus 0.02. When we did random errors, we learned that the errors can be in the positive or negative, right? Now here we have gotten a set of values which has both positive and negative. If you add them, it might just cancel out each other and you can get an error as 0. Okay, but that's not the case. There is some error that we are getting, right? So because of that, what we are going to do is, whenever we take absolute error, this is absolute error. From here we are going to find what is the mean of the absolute error. But when you take mean absolute error, we are going to take the positive value. Even if we are going to take all the modulus of each of the values. So when you take modulus of each of the values, the negative values will also become positive. Okay. So the third case that you're seeing is actually what is the mean. Okay. Absolute error. Mean absolute error is given by delta mu bar, right? Delta mu was actually the absolute error. Delta mu was the mean absolute error, right? Now this mean absolute error will be what? The summation. We take the modulus of all of these values and divide by. Okay. So we're going to add all of these values. First one is 0.06 and the second value is minus 0.05. But mean absolute error, we take only the positive values, right? So if you take modulus of this particular value, you will get 0.05. Okay, then you have the next value. I'm just going to write all of the values. Okay, 0.7 and let's say you got 0.07, 0.03, 0.02. Okay, 0.03 plus 0.02, right? All of this value, if you divide by how many? 6 set of readings. So you will get delta mu bar to be somewhere around 0.26 divided by 6. So this is going to be somewhere, it is going to approximately be 0.043. Okay, this is somewhere close towards 0. We'll round it off to two digits, 0.04. Okay, Deepa, hello. Okay, this is around 0.04. Now this is your mean absolute error. Okay, which is around 0.04. Okay, Okay, Deepa, what you can do for this is you're qualified unsat and you're in 9th. Okay, what you can do is there might be you're taking the foundation course, right? So Deepa, what you can do is there might be a number down in the description box, right? Or there might be a contact number from the student side, right? You can just contact them and ask them for the details. All right. You can just, even if you're calling the number below, you can just point them out, ask them to point out to the right place and they might be able to help you. Okay. All right. Yes, Deepa. So you can tell them about the same. Okay. And they might be able to help you with, because if you want to take it from the center, they might know which place you are from, right? They might know which place you're from, how far are you from the center. They might have to check all of this, right? Okay, Deepa. So, right. So try calling the number down and trying to tell them that that these are my queries and just point me to the right person and they might be able to help you. Deepa, that's about yours, right? That whether you want to take a Cvsc or ICSE, that's a choice that you can just. So one thing you can do is Deepa, you can try looking at both the syllabus of both the schools. You can see how the structure is for both the schools, right? And then you can make a call based on the same. What's better, that again depends on whether you want what about the schools that are next to your place, right? It also depends on the schools that are next to your place. It also depends on the syllabus wise how everything is good. But 10 and 11th and 12th, what I'm seeing is syllabus wise there's not much of a difference between ICSE and Cvsc. Okay, they're almost the same. So you can just go to both the website, take the syllabus, download the syllabus and see how the syllabus is, and then you can make a call. Okay. Alright, Deepa. Now the next one we want to find is what is the, let's quickly finish this, what is fractional error, right? Fractional error or we saw this was basically our relative error, right? The relative error is nothing but, relative error is given by delta mu bar, right? What is the mean absolute value by what was the true value what we got. Mean absolute value is given by 0.04 and the true value we got was around 1.15, right? 1.51. So from here you can actually see if you're measuring this you will get around 0.03. Okay, I'm going to quickly go finishing it, right? Now when you're talking about percentage error, what will be percentage error in this case? Percentage error is nothing but this value, that is delta mu bar by mu into 100%. That gives you the percentage error, right? So here it will be what? It will be 0.03 into 100%, right? So this will give you around percentage error about around 3%. Now, if you want to write the absolute error in this case, right, what will be the refractive index? For absolute error, if you're writing with absolute error, refractive index will be 1.51 plus or minus, what was the absolute error value we got? We got around 0.04, right? So this value is off by 0.04. Okay, so it could be around 4 from this place. It could be somewhere around 0.48 to 1.48 to somewhere around 47 to 1.55. That could be the absolute error. In terms of percentages, if you're writing, it will be 1.51 plus or minus 3% of this value. 3% is this value. Alright, so this brings us towards the end of today's session. So if you have any doubts about how to find the error value, you can ask me in the chat box. Okay, and before we end the class, one small thing is that there is an ongoing batch and it started only on 8th June. So any previous classes you missed till now, the class recordings will be given to you. You can watch those class recordings, and as I said in the beginning of the class, every 4th session will be a doubt clearing session, right? So you can get your doubts cleared. So you can register soon so you don't miss out on any of the live classes. Okay, if you're planning to take a plus subscription, now it might be a good time, because if you're taking a class 11 subscription, class 12 subscription is absolutely free. So you're just paying for 1 year, but you're getting the course for 2 years. Okay, now the mode of delivery for this course is in English, right? Physics, we will be meeting every 5:15 to 6:15 between Tuesday, Thursday and Saturday. Now, whenever you're taking a plus subscription, there in a month you'll get a minimum of 40 classes, per month. Okay. All right. Now, if you see the amount you're paying, right? Now, whenever you're paying the plus subscription, right? So, minimum of 40 classes means you'll get 10 classes for math, 10 for physics, 10 for chemistry, and 10 for biology. This is the minimum classes you're getting. Okay. Now, whenever you're taking the plus subscription, if you're using my code MTIS10, you'll get a 10% discount, or along with it, you're getting this offer as well. All right. Now, if you want to try the price comparison of how much it is for per class, what you can say is you can take per month how much you're paying, right, after doing this, or take the total fees that you're paying divided by 12 months, you can get per month fees. Per month fees, when you're actually dividing it by per class, right, you can see that you're getting the subscription somewhere between a little over, a little under or over 30 rupees. All right, that's the amount you're paying per class. Okay, that's a really low price, right? And for class 12 also, we have an ongoing batch, so you can check that out as well, right? And we also have a community feature, and in the community feature you can never miss out any update from any of your favorite educators, right? You can share your feedback directly with your community, with your educator via pool, right? And you also have, you can check out the link to the educator community. So in my community link will be below. If you're taking it, since we are also covering, since we are doing unit 1, right, there will be some question based asked from physical unit and physical world, right? Some questions from physical world will be asked in pool type format. So try going towards the community and attending those questions. Now, if in case, right, if you're seeing any inappropriate content in any of the videos, and if you're reporting the same, you can claim a prize as well. All right. And if you like the video, please share it among your friends, and also subscribe to the channel, and also click on the bell icon so you will be notified about the upcoming classes. And before I end, if you have any question, you can ask me. And before that, Deepa has a question. Can I switch schools from ICSC to Cvsc in class 10? Deepa, that's something you need to talk it over probably with some elders and with your teachers, and probably you can take a good call on that. Right, if you're changing schools on the 10th grade. Okay, so I hope that is helpful. And on this note, on this note, I'm coming towards the end of the class, and if you have no doubts, I'll be ending the session now. And thank you guys for taking the class now. And also don't forget that we have upcoming live classes we have the upcoming live classes, the live classes that are happening on the platform. The link is given in the description box, and you can check out the same, you can actually go and enroll for those classes as well. All right guys, thank you.